Okay, so we've learned all of our ways to write a series. Now what we're going to do today is review all of those different ways. So the three main ways are doing your chart, which is the long way, finding the derivatives and plugging into your formula. You can manipulate an e, a sine, or a cosine, as long as it's centered at 0 as a Maclaurin polynomial. And then you can do your geometric if it's in the form of a over 1 minus r. So we're going to review all of those today and look at some kind of AP style writing series questions that you might see. So for this first one, I notice it's centered at 0 and I notice that it contains an e. So I am going to use my manipulation techniques for my e function. So my e to the x is going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 plus x to the n over n factorial. So that's my series for e. So when I'm going to write my series for x squared e to the 2x, I am going to manipulate that series. So I'm going to start by multiplying that series by an x squared, and then I'm going to put a 2x everywhere there's an x. So it'll be a 1 plus a 2x plus a 2x quantity squared over 2 factorial plus a 2x quantity cubed over 3 factorial plus dot 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 plus a 2x to the n over n factorial plus dot dot dot. And so if I simplify that, I distribute and clean up my two x's. I'm going to have an x squared plus a 2x cubed plus, okay, so this is going to be a 4x squared times x squared will be a 4x to the 4th over 2 factorial plus, this will be an 8x cubed times x squared, so an 8x to the 5th over 3 factorial plus dot 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 plus, this I'm just going to write it as x squared times 2x to the n over n factorial plus dot dot dot. So there is my series where I manipulated my e to the x. Okay, the next one with the square root of x plus 1, it's not in geometric form. It's not one that we have memorized, so we're going to have to use the long method. So remember, our long method is we need our chart. So we're going to have n, we're going to have the nth derivative at x, and we're going to have the nth derivative at 3. Now, one of the common mistakes that you'll make is instead of plugging in your center, you plug in your n value, and that's wrong. You're always going to plug in your center. So we start with n equals 0, so that would be our original function, square root of x plus 1. So if we plug in 3, 3 plus 1 is 4, square root of 4 is 2. Now we want, let's write the first 4 terms. So we're going to go with n equals 1. So the derivative of that is 1/2 times x plus 1 to the negative 1/2. So that's going to be 1/2 times, well, 4 to the negative 1/2 is 1/2. So 1/2 times 1/2 is 1/4. Okay. The next one for n equals 2, our derivative is a negative 1/4 times x plus 1 to the negative 3/2. So 4, square root of 4 is 2. 2 to the negative 3rd is 1/8. 1/8 times negative 1/4 is a negative 1 over 32. And then finally for 3, if I bring down, I get a positive 3 over 8 times x plus 1 to the negative 5/2. So plugging in 3, 4, square root of 4 is 2. 2 to the negative 5th, 2, 4, 8, 16, 32. 32 times 8, I don't know what that is, so let me figure it out real quick. 32 times 8 is 256. So that would be a positive 3 over 256. Okay, so now remember our formula is the nth derivative at c times x minus c to the n power over n factorial. So that's going to be the formula that I plug it into. So now we're starting at 0. The nth derivative at 0 is 2. So it would be, I'll write it down here, 2 times x minus 3 to the 0 over 0 factorial plus my next derivative is 1/4 times x minus 3 to the first over 1 factorial. Let me put it so you can see it. There we go. Minus my next derivative is 1 over 32 times x minus 3 squared over 2 factorial plus my next derivative is 3 over 256 times x minus 3 cubed, that's supposed to be a 3 there, over 3 factorial plus dot, dot, dot. We won't worry about writing the general term because this one is one that really doesn't have a good general term. Okay, so that was a review of the long method. We try and avoid that method if we can, but it's always there. All right, the next one, we have f of x is equal to 3 over 2 minus 4x. So this one is very close to the geometric form. Remember, the geometric form is f of x equals a over 1 minus r. So the only thing we need to do is take this 2 and make it a 1. So we're going to divide by 2 everywhere. So that's going to give us f of x is equal to 3/2 over 1 minus 2x. 4x divided by 2 is 2x. So that means our a value is 3/2 and our r value is 2x. And so remember to go write our series. We write our a term on the page, so 3/2. Then we multiply by the ratio, so 3/2 times 2x is a 3x. Then we multiply by the ratio again. 3x times 2x is a 6x squared. Then we multiply by the ratio again. So that would be a 12x cubed plus dot, dot, dot. So my general term is going to be 3/2, that's my a, times my ratio 2x to the n power. And that's my general term. So that is my way to write it when it's in geometric form. Okay, so now we're going to get into ones that are a little trickier. So here we have the function f of x equals natural log of 1 plus 4x. Now, a lot of times when I have a natural log, I like to use integration techniques because I know f prime of x would be 4 over 1 plus 4x. If I use the chain rule, it'd be 1 over 1 plus 4x times the derivative of the inside, which is 4. This is a geometric series. I know my a value is 4, and I know my r value is negative 4x. So it would be 4 minus 16x plus 64x squared minus, what's 64 times 4? 256, 256x cubed, and so on and so forth. So there is my series for the derivative. Now, if I want the antiderivative, then I can just go through and take the integral of that. So f of x is equal to the integral of f prime of x, which is going to be the integral of 4 minus 16x plus 64x squared minus 256x cubed plus dot, dot, dot dx. And I know this looks bad, but remember it's just a polynomial. So each piece, the antiderivative of 4 is 4x. The antiderivative of minus 16x is a minus 8x squared. Antiderivative of 64x squared would be a plus 64 over 3x cubed. The antiderivative of 256 over 256x cubed would be a minus 64x to the 4th plus dot, dot, dot. Now, if you needed your general term, let's see, your general term for this guy up here would be 4 times a negative 4x to the n power. So if we integrated that, that would be a 4 times negative 4x to the n plus 1 power over n plus 1. So that would be our general term plus dot, dot, dot. So you remember that integration and derivation work the same with series as it does with any other polynomial. Okay, now these are ones that have started showing up on AP style problems. So it says a function f has a Maclaurin series given by 2 minus 3x plus 4x squared plus minus 5x cubed. And the Maclaurin series converges to f for all real numbers x. Okay, that just means that it's a convergent series. G is the function given by g of x is equal to f of x quantity cubed. What are the first three terms of the Maclaurin series for g? So we need to do this the long way because this is not one that I've memorized. So I'm going to build my chart. So I've got n, I have g to the nth of x, and then I have g to the nth of 0. So if I start out, my original function is f of x quantity cubed. Oops, just kidding, that needs to be a 0. So then my original function is f of x quantity cubed. So this would be f of 0 quantity cubed. Now, here's my equation for f. Here's my polynomial for f. So remember that f of 0 is going to be the coefficient, which is 2, times 0 factorial, which is 2. So 2 cubed is going to be 8. Now we need to do n as 1, so I need to take the derivative of this, which would be 3 times f of x quantity squared times f prime of x. So now if I want f prime of 0, remember it's the linear coefficient, negative 3, times 1 factorial, which is negative 3. So this is going to be 3 times f of 0 squared times f prime of 0, which is going to be 3 times 4 times negative 3. 3 times 4 is 12. 12 times negative 3 is a negative 36. And we got to do it one more time because we want the first 3. So now we're going to have to do product rule. So it's going to be 3 times f of x quantity squared times the derivative of f prime, which is f double prime of x, plus, now I'm going to take the derivative of the first term, which would be 6 times f of x to the first times the second guy, times the derivative of the inside, which is f prime of x, then times the second guy, which is another f prime of x. Okay, so what is that one? That one is going to be a 3 times an f of 0 squared times f double prime of 0 plus, then we're going to have a 6f of x, so 6f of 0 times, then we've got 2 f primes here, so this is going to be f prime of x quantity squared, x prime of 0. Okay, so f double prime of 0 we need, so f double prime of 0 is going to be the quadratic coefficient 4 times 2 factorial. That'd be 4 times 2, which is 8. So this guy is going to be 3, I'm going to have to write it all out. 3 times f of 0 is 2, 2 squared is 4, times f double prime of 0 is 8, plus 6 times f of 0, which is 2, times f prime of 0 squared, so negative 3 squared would be 9. So what does that equal? Let's do it on the calculator. 3 times 4 times 8 plus 6 times 2 times 9. That gives me 204. Oh my goodness. Okay, so now we're ready to write our series for g. So we're going to take our first derivative, our original function value, so it'll be 8 times x minus 0 to the 0 power over 0 factorial, plus our next value is negative 36. So negative 36 times x minus 0 to the first over 1 factorial. And then the next one is a plus 204 times x minus 0 squared over 2 factorial. And then we'd have a plus dot dot dot. So we could keep going, but that would be really painful. So we'll stop there. All right. The other way that they do it is they give you an expression for the nth derivative. So in this way, we've got to build our chart. So I'm going to, let's see, it says write the first 4 terms in the general term. So I need 4 terms. So we have n, we have the nth derivative at x, and then we have the nth derivative at our center, which is 5. We're centered at 5. Okay, so now when we plug in 0, this is going to be f of 5. So f of 5 they gave us was 1/2. So that one was pretty easy. At 1, it's going to be f prime of 5. Now, they didn't give us an equation for the original function, but they gave us an equation for the derivative, and it's in terms of n. So f prime of 5, my n value is equal to 1. So I'm going to have negative 1 to the first times 1 factorial over 2 to the first times 1 plus 2. So that's going to be how I get my derivative value. So negative 1 to the first means we are negative 1 on top. 2 times 3 makes 6. So our first derivative is negative 1/6. Okay, so now we're going to do that for 2. So we want f double prime of 5. So in this case, n is 2. So plugging into our derivative formula, we're plugging into this guy right here. It'll be a negative 1 squared times 2 factorial over 2 squared times 2 plus 2. Okay, negative 1 squared goes positive. 2 factorial is 2. On the bottom, 2 squared is 4. 4 times 4 is 16, so that would be 1/8. We got to go one more time because we need 4. So we're going to go 3. So that would be f triple prime of 5. So n is equal to 3. So plugging in up here, we have negative 1 to the third times 3 factorial all over 2 cubed times 3 plus 2. Okay, negative 1 cubed means negative. 3 factorial is negative 6. On the bottom, 2 cubed is 8. 8 times 5 is 40. If I take out a 2, I get a negative 3 over 20. Okay, so now I can go write my series. So I'm going to start with 1/2. So it'll be a 1/2 times x minus 5 to the 0 power over 0 factorial, plus I'm going to negative 1/6 times x minus 5 to the first over 1 factorial, plus my next value is 1/8. So 1/8 times x minus 5 squared over 2 factorial, plus my next one is negative 3/20. So negative 3 over 20 times x minus 5 to the third over 3 factorial. Now, when it comes to writing the general term, what we're going to do is take this horrendous equation and we're going to plug it in where that derivative value goes, because that's how we've been getting our derivative value. So we're going to write it as negative 1 to the n times n factorial over 2 to the n times n plus 2 times x minus 5 to the n all over n factorial. And then we put our plus dot dot dot. So we just insert that terrible derivative equation in place of the derivative numbers. That's our general term. And so that would be our final answer. All right, so I know those last two were a little bit more difficult, but I promise if you just go through the steps, then you can get it. If you have any questions, come see me, guys. Bye-bye.